Alright guys, want to make this video for the 7.1 notes. We did have a lab that went with this, so if you were in class, hopefully you have that. If not, you can always get that from me if you were not in class that day. But in any case, I have a little extension with these notes, and so we're getting into Unit 7 here. So if you have not already, I would like you to label a new unit in your notebook. It's going to be Unit 7, and in this unit we're talking about quadrilaterals. Okay, talking about quadrilaterals, that is our main focus, or in other words, four-sided shapes. Before we get into dealing with some of the things with four-sided shapes, we need to know information about shapes as a whole, or in general. And so that's why we're doing this today, 7.1, angles of polygons. Date today is the 8th or the 9th, depending on what class you have here. Okay, and our objective is we're going to use this information that we figure out about polygons and what we talked about in the lab to solve problems for angles inside a shape and angles outside of a shape, or in other words, the interior and exterior. Okay, so first off, a few definitions and a few terms that we need to make sure we understand as we go through these kinds of problems here is what I mean when I say a polygon. Okay, so a polygon is just a closed figure. Okay, a closed figure with a certain amount of sides. Okay, so the technical definition of a polygon is just a closed figure with a certain amount of sides. Or in other words, it's just a shape. So really, when I say that word polygon, that's all we really need to think about is just some kind of shape, depending, and specifically it has a certain amount of sides. And we'll get into what those look like when we start dealing with some different problems here. Okay, next term that we need to know here is what we call a regular polygon. Okay, a regular polygon. And a regular polygon is a shape whose sides and angles are all congruent. Okay, a shape whose sides and angles are all congruent. So, for example, one way that we've seen this so far is when we were talking about triangles, we talked about types of triangles that have all the same sides and all the same angles. So I'm going to go ahead and draw that here. And I don't need to necessarily mark exactly what they are. I can just put a dash mark on all the sides and then an arc on all the angles. Okay, remember this was an equilateral and an equiangular triangle, and this would be an example of a regular polygon. Okay, three-sided shape, all the sides are congruent to each other, all the angles are congruent to each other. It doesn't necessarily mean the angles and sides are congruent, because remember the angles have to add up to a certain number, sides do not, but it just means all the sides are the same, all the angles are the same. Okay, and then this kind of leads us to this idea that we have here, which is called the polygon interior angle sum theorem. And this is one of the theorems that we kind of investigated and hopefully were able to kind of nail down as we were looking at those different examples of shapes. Okay, and the polygon interior angle sum theorem, I know that's a mouthful, says this. It says the sum of the angles inside a shape. So remember, sum meaning what I get when I add them all up, of the angles inside a shape will always be, okay, and we have this equation for it. The equation is in parentheses n minus 2 and then times 180. Okay, n minus 2 and then times 180. Okay, and then I'm going to add a little piece at the end here. I'm going to say with n being, or representing, I should say, number of sides. Okay, with n being the number of sides. So this is an equation. I want you to circle this, underline it, or highlight it in your notes somewhere. Make sure it stands out, because this is one that you're going to need to use as we work through different problems here. Okay, and all this equation is really saying is we want to figure out how many triangles are in a shape. And the way to do that is to take the number of sides and subtract 2. Okay, and then once we find the number of triangles, we know all the angles in a triangle are supposed to add up to 180. So I can just do n minus 2 and then times 180. Okay, and if you have any more questions about that, you can obviously let me know in class. Okay, so first example here. Okay, I'll cut off that definition for now. If you'd like to, you can pause your video and sketch this shape here, but we want to use that theorem that we just talked about to find the value of x. So if I'm looking at this here, what I need to do is I need to find the sum. I need to figure out what all these angles are going to add up to. And if I look, this is a hexagon, or in other words, a six-sided shape. So if we're going to use that theorem that we just talked about, or we want to use the sum, remember all I need to do is n minus 2 and then times 180. Okay, so in this case, n, or the number of sides, is 6. So I'm going to go ahead and just plug that in. Whoops. So I have 6 minus 2 and then times 180, and this should give me the sum. So I'll go ahead here. I'll just simplify this. This is 4 times 180. And if we didn't know this, we could just type this into our calculator, and that's going to give me 720. Okay, so this is the sum. This is what all of the angles should add up to. And now that I have that number, we're going to solve this just like we would with triangles. We take all of our angles, we add them up and set them equal to that number. So I have all my angles here. I'm just going to go around the edges and get each angle. So x plus 2, x minus 4, x plus 6, and so on and so forth, including all 6 angles here. Okay, plus x minus 8, all equals 720. And if I did this correctly, I should have 6 different angles or 6 different expressions here. And if I look, I do have 6 different angles or 6 different expressions. And now I can combine my like terms. So I have x, 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 so on and so forth. I'm combining all the x terms. There's 6 of them, and they're all just 1x. So adding them together, that's just 6x. And then when I do the same thing with the numbers here, I have a positive 2, negative 4, positive 6, negative 3, positive 7, and negative 8. And I can take the time if I'd like to and see what these are going to come out to. And actually, this one's actually pretty nice. These actually cancel each other out because the positive 2, and negative 8 cancel each other out, and then the negative 4, negative 3, and positive 7 all cancel each other out. So actually, it's just 6x plus 0, or in other words, if it's plus 0, I don't even need to write it. So really, I'm just left with, when I combine all this, 6x equals 720, and now I can just divide by 6. And I'm going to get x equals 720 divided by 6. If I didn't know this, I can just type this into my calculator, and that's going to be 120. And then, of course, as always, if I'd like to, I can plug these back in and double check and make sure they all add up to what they're supposed to. But this is all I need for this. It's just finding x. Okay? So that's how you find the angles inside a shape. And then we also had a theorem that we talked about for the angles outside of a shape. And this one's a little bit simpler. If we're dealing with the exterior angles, this theorem is just going to say this. The polygon exterior angle sum theorem says this. It says the angles on the, the sum of the angles, outside a shape will always be 360 degrees. Okay, so that makes things a lot nicer for me. I don't have to figure out how many sides there are and then use that to find the sum. The sum is always going to be the exact same number no matter what. It's always going to be 360. And the only thing I need to make sure to do here is I just need to make sure to include all the exterior angles, because I need all of them to add up to 360, not just some of them. Okay, so example 2, this will be our last example for today. If you need to, you can pause your video and sketch this here. But if I'm looking at this, I want to again use that theorem that we talked about to solve for x. And just like we saw, if I'm trying to set up this equation here, it doesn't matter how many angles there are, those are going to add up to 360. So all I need to do is add them all up. So 2x minus 5 plus 3x plus 10 plus 6x minus 5 plus 2x and plus 5x. So I have 5 exterior angles, and those should all add up to 360. Okay, so that's all I need to worry about. And now once I'm here, I can just combine my like terms and solve. So let's combine our variables first. We have 2x, 3x, 6x, 2x, and 5x. If I add those up here, I'm going to get 18x. Okay, and then same thing with the numbers here as well. I see I have negative 5, positive 10, and negative 5. And we notice that actually the same kind of thing happens as the last example. The two negative 5s and the positive 10 are going to all cancel each other out. And so this equals, not equals 720. All of those combined just equals 0. So I could say 18x plus 0, or in other words, just 18x equals and then remember we have 360 there. Okay, so the numbers won't always cancel each other out, but on these problems, I've just made them a little bit easier so we can just focus on the setup, and then you guys can do the algebra. Okay, and then last step here, all we need to do is divide by 18. And I get x equals 360 divided by 18. I can just type this into my calculator if I don't know, and that's just going to be 20. Okay, so those are the two things that we need to know how to do for today. Do I know how to add up all the angles inside a shape? Doesn't matter if it's a triangle, 4-sided, 5-sided, so on and so forth. And do I know how to find that sum? And then on the outside, do I know how to make sure that they all add up to 360 and then be able to solve from there? Okay, so that's all the notes for today. Like I said, make sure you do that lab as well if you have not already. And then if you guys have any questions, feel free to let me know. All right, thanks guys.